Welcome, lads and ladettes, to Aether Roundtable number 104, Community Showcase, celebrating 2 years.
All right, hello and welcome everyone. Tonight we're going to be going over the community showcase. We got a couple of prezzies from community members, and we're also going to talk about just some various things that we've all learned over the course of the last 2 years that we've been working together and putting together these prezzies. And hopefully this will be a nice time to go through and recap on some stuff. So before we get into the video prezzies
And
here,
we are told
we'll actually no, we'll just get into we'll start with Vambi's
that
presentation first.
in
So we
this
got a
photo
nice
we are
10-minute presentation on refraction, and then we'll go from there.
Nice. All right, I think I can play it. So Vambi, this is Vambi's channel. Did Vambi make this?
Yep, this
It's
is
on
for
my channel,
for us. Yeah.
Nice.
Oh, go ahead, Vambi.
I just didn't know he was in the video making business. I might have requests after this.
No, I don't have other videos. It's just my YouTube account. So,
But this is proof of concept now. But okay, here we go.
and this is a presentation on refraction. And specifically, we are going to be
I'm a little nervous. I haven't done a
common
Prezi since high school, so it should be good.
The first one's fun, especially if you do it pre-recorded. But as you do more, it gets easier.
Tapping the stream.
Plus, this is like the best community to present in front of. It's full of supportive peers who just want to hear you talk, right? So it's cool. One of the best. You guys ever
Why I'm here?
demonstrations used to back up the claim that refraction can effectively allow an observer to see beyond the geometric curve of the Earth. So here we have a very well-known photo of the Chicago city skyline, and we are told that in this photo we are not actually looking at the physical buildings, we are looking at the effects of refraction, because the buildings are roughly 60 miles away from someone standing on the shore, and you should not be able to see that far according to the globe curvature formula, curvature rate. So this is the claim we are examining, that refraction can cause this effect. In this presentation, I'm going to focus specifically on examples that introduce a second medium. And that would be image formation at the boundary interface. And that's what I want to talk about, and what I've learned about recently that I think is important in this conversation, because the demonstrations used to prove this claim that refraction can bend light around an obstruction so we can form an image, the observer can form an image. This claim, these demonstrations are often used to back up that claim, and I think they are not analogous to the claim they're trying to back up. So these pictures here in this demonstration are from our good buddy Jesse Path of Light, and I got him from his YouTube channel, and I thought it was a decent demonstration of what we're about to see here. So a camera is looking out a window, and it has line of sight to a house that's across the street, and Jesse has put this obstruction here so it's physically blocking the house that is behind it. And then he adds a prism to the top, which is a secondary medium, and then all of a sudden the house is refracted around the obstruction. And I think he even used this rounded opaque obstruction at the bottom here to represent the curve of the Earth. And so this is a demonstration showing, hey, look, refraction can bend things around the curve. But what I hypothesize is going on is something very specific to the introduction of the second medium. It's not analogous to refraction within a single inhomogeneous medium. This is specifically when you add the second medium. So here's a little chat GPT definitions here, and I just want to define image formation at a boundary interface and talk about it. So image formation at a boundary interface is the creation of a real or virtual image due to the change in direction of light rays at the surface separating two optical media of different refractive indices. So we have image formation is the creation of images due to the change of light rays at the boundary between two different media. That's what image formation at the boundary interface, and it's specifically because of the change in direction of light rays. So and I'll talk more on that, but the boundary interface here, it says the physical surface where the refractive index changes abruptly, e.g. air, glass, air, water, etc. The keyword here is abruptly. So the light is going from one medium with a refractive index, and then it's entering another medium with a different refractive index. So there's a jump, there's an abrupt change, and a change in the direction of light rays. So I think that is very significant when talking about refraction. That this effect happens specifically at a boundary interface. It does not happen within a single medium. So here's just a quick diagram. We have the two mediums, and it's showing the boundary interface right in the middle. And so medium one could be air. We have the incident ray coming from the top left. This is the light ray from the object or whatever. It's hitting the second medium. This could be the prism in our case, a prism or water or something. And so it enters the different medium. It hits the boundary interface. Light abruptly jumps to the different refractive index, and it is at that boundary interface that an image is formed specifically. So here's another example that I took at my apartment with my sink, and this is just highlighting the boundary interface again. We have a sink, we have an observer looking down at the sink, and the drain at the bottom of the sink is obstructed by the lip of the basin. But when we fill up the sink with water and remain at that same angle of observation to the sink, the drain reveals itself. It has lifted up to our eyesight, and this is specifically because of the boundary interface. So the light comes from the drain in the water, it hits the boundary between the water and the air, light jumps refractive indices, it changes abruptly, and then that which allows for a virtual image to form, which we can see. If I take it one step further and I keep filling up the sink with water until the whole bathroom is filled up with water from the floor to the ceiling, and the observer's in there too, this is what I think you would see. There would be no boundary interface, and this is just to highlight how it's the boundary interface specifically that is causing this refractive effect. This refractive effect does not happen within a single inhomogeneous medium. So quickly, I want to just define an important term, which is inhomogeneous medium. So an inhomogeneous medium is one in which the refractive index varies smoothly with position. So we're talking about air, or the atmosphere. It has a density gradient. It is an inhomogeneous medium. So it varies smoothly with position, for example, with altitude in the atmosphere or depth in water. So unlike refraction at a sharp boundary interface, like air glass, there is no discrete jump in the refractive index of n. Instead, n changes continuously through space. So this is highlighting that within an inhomogeneous medium, there is no, it's a smooth, continuous, gradual path that the light is bending. There is no sharp change, therefore there is no image formation. So here's a quick just diagram of a light ray bending in an inhomogeneous medium. In the middle you see the darker region is the denser part of the gradient, and you have light rays coming, like the top light ray, it's entering the medium, it's in the medium, and it's traveling down gradually and continuously toward the denser medium. So this is just how the light ray behaves within an inhomogeneous density gradient. And so here's just a couple more quick examples. This one's not the best, but I got this from Jaren's channel, and this is someone filming the display of a camera, so that's why it's a little wonky. But what we see here is that what they're showing here is a ball, and from this vantage point, you cannot see anything on the far side of it. But when he puts a glass lens in front of the ball, then the pin or whatever on the other side of the ball is revealed. So this is just another example of adding a second medium, creating a boundary interface, which creates that virtual image because of the sharp bend that the light travels from different refractive indices. So I think this is the final slide, and I'll just end on this. This is a little meme I got from New Perspective, but in all these examples here, what needs to happen to show, we're talking about the claim of light bending around an obstruction, aka the curve of the Earth, and so it's an obstructed object that we are forming an image of, that is supposedly being lifted around the obstruction of the curve of the Earth. So that's the claim. But these examples and all these examples, they are not analogous to the claim, and they are used as evidence of the phenomenon. So in all these examples, a second medium is added, which creates the boundary interface, which allows for a virtual image to form due to refraction. So I think that's what's happening here, and I'll just end it on that. Thank you.
Nice. Dude, you're so confident.
Dude, that was awesome.
Right?
That was
so
awesome,
great.
Bambi.
It sucks listening to yourself talk, for sure.
Dude,
Yeah,
it's the
you
worst,
get over
right?
it. You get over it.
But no, you crushed it, man. That was fantastic, dude. That was great pacing. I like the way that you did definitions and then like went over them with the examples as you continued through. That was great. And then the difference between the inhomogeneous medium versus the abrupt sharp change that to create the image. Dude, I didn't get what you were saying the other day, or it was like a week ago now, when you were talking about the boundary layer and the interface, dude. Great presentation. Now I
Cool.
fully understand what
Appreciate it.
what you were talking about now, and that you nailed it, man.
Yep.
That is
Thank
that is fantastic. And then to end it off with the example of them using a non-analogous scenario as evidence of the phenomenon is, dude, that's great. They can't add like more water or air or like, to get it. They have to add like a completely different medium to get that interface, to get that snapshot of the image.
Right. Yeah.
Great demonstration, man.
But yeah,
Crushed
dude,
it.
Thank you.
for a
Bambi.
first time, it was epic, dude. Look at you confidently switching back and forth to slides as what you're covering and spitting off the tongue kind of goes back. You
From
go
the
back
light
to
rays.
show.
Boundary.
That's all like acquired skill that you came out the gate with. That's awesome.
Oh, I've watched pretty much most of all your guys' prezzies, so that's where I'm getting my my tips from.
Nice.
Anyone else comments?
And yeah, on the Chicago skyline, real quick. Remember our boy Jim, our man in the field, used to go
What was
out
his
and
favorite?
film the skyline multiple times a week, because you know how after that guy with the news or whatever, it became like a big thing, and then they downplayed it, and they were like, "Oh,
to do it.
you can only see it sometimes of the year." My boy moved there to go and film it every day. He went out every day. Now there were some days, I think this was during one of the fires or something or whatever. So there was some days where you couldn't film, but I mean, like 4 out of the 7 days of the week when you could film, he would nail it. He would go out and interview people on the beach and be like, "Yo, do you see this often?" Yeah, all the time. Nobody,
Yeah.
no local there was like, "Nope, never happens, never met her."
Right. and when the conditions for refraction to even be plausible, if you grant it you have to have like extreme, temperature inversions or whatever they say, like, and so, but if you're just witnessing it constantly, it's kind of statistically not there. Yeah.
How would
Yeah.
you apply it specifically to the celestial theodolite, or would you in homogeneous medium, or it's happening, right, or not?
Right, that's a good question. Well, I guess I would postulate that you can't. I I guess the train of thought I'm going down is you need geometric line of sight to the boundary interface, and I think all laboratory experiments
Ooh.
show that within one inhomogeneous medium. So basically, it when you can't see something that's geometrically blocked to line of sight. It is the claim I'm kind of pursuing. So I guess that's how it would apply to the celestial theodolite. If something is,
I like it.
yeah,
Nice.
it's a good question though. I
Yes,
have to think about it.
as soon as I heard your topic, I'm like, oh, he can definitely eloquently apply this directly to the South Theo, but I want to see how he does it. And I was like, just because I can't think of how to do it right away, and you definitely nailed it. Excellent. Dude, yeah, you need geometric line of sight to the to the boundary layer transition in a homogeneous medium, Alan. That's how we should say it.
Yeah.
Yeah, I would agree with that. I mean, that's what I think it's what experiments show. And until they can, create an analogous experiment, then there's also the laser claim, which you know they show the lasers bending through the gradient, but I don't think that's analogous either. That's a whole nother subject, but
Nice, dude. That was a great first showing. I'm super impressed. I love this community so much that we can just do this, and you guys come through with awesome, epic things that we did that are so like congruent and helpful and on point. Thank you, man.
I'm just happy to be here. Thank you guys.
I think Flat Earth attracts a lot of really smart people.
Truthers, smart people end up as truthers. Truthers end up as flat earthers, right? That's the natural progression. All the various truthers are at different
No,
stages of that.
if you're really seeking truth, what you'll do is you'll end up in endless conversations with no resolution. And anytime there's a conclusion about to be drawn, you'll divert.
And then you'll just spend
And
all
I'll,
your time talking to the same people.
Yeah.
and
Making
also
sure
for
that no conversation advances. Yeah.
like my case, I most of the time feel like I'm retarded, and it's the fear of that makes me almost try harder and double check all my, dot my T's, cross my I's, and make sure I'm understanding things correctly, and watch an extra video or two, and do a little bit more reading or whatever, because I'm scared that I am an idiot and I'm getting all this wrong. So
Yeah, no,
yeah.
No, that's great
I was
motivation,
gonna
and
say that's healthy.
that's what I used.
Yep.
Yeah, that's what I used to make sure. And then when I first did Prezi, it was on general relativity, and the people that were like listening, there were some people that were trying to refute some of it and stuff, but like none of them really knew anything about what was even being said, and like they claimed to be the ones that believed in it. And then later on at the end of the Prezi, uh Professor Parks was like, yeah, you didn't. He's like, I disagree with what you with like how you said what you said, but you didn't really say anything super wrong. It's like having that confident, like going through and double checking and making sure that you're right is is what leads to the full steel man of their position, and then you can really realize how ridiculous it is.
I also think
Right.
I think it's healthy to start with "Am I the retard?" though when you're bringing up presenting on topics.
Yeah,
I
dude.
really think that's a healthy starting point, because most of these super arrogant, conceited people don't ever even check that, and then you get people who are super confidently wrong, right? And that's something that I'm always worried I'm going to be. So yeah, no, I definitely try to check myself all the time, especially when doing
Yeah.
new topics that aren't like well thought out and well researched, right?
Like, is
Yep.
there a potential that I'm the problem?
Yes,
That is a
always
huge
start
part
there.
of
Yes.
the huge.
Yeah,
That's so funny.
it's smart and honest versus full of hubris and lacking critical thinking skills. Yeah.
Right, because if it passes the am I the retard test, then the next test is bounce it off the boys, and then bounce it off, and then do a prez, and then bring it to the opposition and the strong opposition, and then see how it goes. Right, that's the evolution of a new concept or argument.
Yep. All right. Well, let's keep it going here. Angling has a Prezi, but he's gonna deliver it live. So next time he's on, we'll just have him do it. But we can move on to Brian's Cell Theo Prezi now.
Nice.
Ooh, Brian. I noticed he snuck into SCT yesterday, too. Very cool to see.
Nice.
I like an Ether subcult that I'm not part of. What is that?
That's Telegram, the Stone Cold Truth channel.
Oh, okay. So kind of, yeah.
Yeah, he
Little
just
side
kind of
projects
snuck
of
in
Stones
there
that
and
he's been
started
managing
looking
for 6
around.
years.
Never said nothing.
Yeah, do you have the link, Shane, or do you need me to acquire it for you?
No, I think I have it. I just haven't opened Telegram in like weeks. I only use it to reference
No,
other stuff.
I meant to Brian's video.
Oh no, I don't have Brian's
Exactly.
video.
Yeah, I got you. I was wondering why it wasn't immediately being
Oh,
shown.
I thought Brian was gonna share his own video. Am I sharing his too? Okay.
Oh shit! I mean, you're gonna put it on the man like that?
I sure am, as much as possible.
Nice, Brian. Do the thing and do it live.
Have you got the width, Brian? Come on,
To
buddy.
be honest, I've never
Show
tried,
us
so I
your
don't know how
stuff.
well it would go.
First time for everything, as they say. I'll of course do it if it breaks and you can't do it and you have like Allen level internet or whatever, but I doubt that'll happen.
Allen level internet,
Yeah,
dude.
you're now a meme, dude, because you don't have internet for 2 weeks. How's that?
That's fair.
Bri, where you at, man?
Sorry, I forgot where I put the video.
Nice.
No worries. And then also, there's been additional things that you've found since you made this, or have you made like a revised version?
It's not really ready for the revised version.
Nice. Okay, cool. So we'll definitely go over the patch notes then.
Respect.
Oh, just for clarity, I was talking about the other Brian. Brian Sweet.
Yeah, I figured that that's what was happening,
Yeah,
but also
yeah.
Brian is on Telegram, and I was pretty sure that he might have joined yours, and I was like,
Yeah,
could
he
be both.
also
He
cross-fed,
may
and he's
have.
also named Brian on Telegram, so...
Yeah.
I
Mind
just
if I call you the new Brian, just to keep it clear?
But welcome, Brian Sweet, not to be confused with L'Amazing.
well, thank you very much. But I just checked out that Telegram.
Yeah, man, stick around. There's all kinds of shit. It's almost 200,000 posts in there to check out.
Yeah, I hardly ever go over to Telegram, so there was a couple other ones that just kind of faded out.
All right, Brian, here's a link to the video if you just want to screen share the YouTube upload of you doing the
Oh yeah,
thing.
that's what I meant.
Since Shane's making you do it for some weird reason.
Oh, you sent it to me. All right, I got it.
Yeah,
Hello.
we just need a thing done. I don't care who does it. Buddy, if Brian starts streaming right now, I'll tune in and watch it. Like,
All right. Well, and
That's right, gang. Aether Cause, the head of Smooth Operations TM. That's us.
well, listen, we didn't plan nothing.
the very definition of we'll do it live.
Okay. Stream's not. Nope. We gotta go back over here. All right, everyone sees it, and I'm ready to play if you are, Brian. All right. Thanks, sweet. Thanks, other Brian. Everyone tuned in? We good to go?
Hello, this is Lamazing, and I'm going to present a new application for the celestial theodolite today. But first, let's recap what it is for those who don't know. The celestial theodolite uses observations of stars setting behind mountain peaks. By noting the exact second where the star was no longer visible, you can then consult an astronomic almanac to determine the uncorrected angle to the star at the time, as in not influenced by refractive and other optical effects. By forming a right triangle at the base of the observed mountain with the other 2 points at the observer and the mountain peak, the geometric angle to the mountain can be easily calculated using basic trigonometry, where the angle is the arctangent of the height of the peak minus the height of the observer for this vertical distance divided by the ground distance, which is also going to be equal to the angle to the star from the almanac. It is interesting that the physical angle to the peak of the mountain comes out the same as the almanac angle to the star, despite there being no allowance for Earth curvature in the calculations. Most of the observations are done at long enough distances away that the amount of ground curvature would be significant. When the calculations are done using globe math, and that accounts for the curvature, the numbers are off by the amount of ground curvature present. Refraction, the bending of light due to the changing density of the atmosphere, has to be invoked to compensate for that difference, bringing it back to where it would be without the curvature. The following celestial theodolite measurements have been made to date, sorted by observation distance. The farthest one done so far has been to North Peak in Colorado, with a distance of 130,000 meters. But instead of discussing stars getting occluded behind mountain peaks today, let's try something new and completely shatter the current longest distance observation, which is going to be 7.7 million meters, which is 60 times the furthest record to date. And here's what we're discussing: solar eclipses. A total solar eclipse occurred on April 8th, 2024 in the United States, with totality lasting from 4:30 p.m. to 8 p.m. UTC time, and that was 4.5 minutes at any one given location. Noteworthy cities along the path are Austin, Texas, Dallas, Texas, Little Rock, Arkansas, Indianapolis, Indiana, Toledo, Ohio, and Rochester, New York. The path was going from the southwest to the northeast. And then, of course, the sun and moon are traveling from the east to the west. And the reason that the eclipse path travels from west to east is because the sun outpaces the moon, swinging the shadow around as it passes. The reason the path of the eclipse travels north is because the sun is getting farther away from the moon, making the angle of the shadow down to the ground more shallow and thus farther reaching. So now we've got to understand the eclipse. Where to begin? First, I want to understand why the path of the eclipse shadow would travel to the north. So the first thing to do is study the movement of the sun and moon in Stellarium, which is a planetarium app showing the position of the stars for a given location and time. Starting at the farthest point for the eclipse shadow, I drew a great circle route to the moon. Then at intervals of 1 nautical mile, which is 1/60th of a degree of longitude, I used Python to calculate the latitude and longitude coordinates for each of those interval points. I also recorded the observer's altitude angle to the sun and moon, which excludes refractive effects. And then I plotted the angle versus ground distance for both the sun and the moon. So starting here with the sun, the first step is to create a linear trend line of the plotted data, which you can see is this dashed blue line. And the R value is high, indicating it's a good match, or close to 1 rather. The slope of the trend line gives rise over run, so the slope value of -9 e to the -6 has units of degrees per meter. Vertical is degrees, and the horizontal is millions of meters. When we take the inverse, 111,000 meters per degree, and then divide by 1852, which gives us 60.038 nautical miles per degree. This is close to the expected 60 nautical miles per degree, where the sun drops by 1 degree for every 1 degree of distance traveled. Going back to this 111,000 meters per degree number, if we multiply by 360 degrees to get the circumference, and then divide by 2 pi, we get the radius value of 6.3 million meters. This is close to the 6371 radius for the Earth value, which is what we'd expect. But now when we go to the moon, something interesting happens. If we generate the trend line like before, this gives us 9.13 e to the negative 6 degrees per meter. We invert to get 109,000, and then when we divide by 1852, we get negative 59.1327 nautical miles per degree. Most unexpected. And then when you continue the math out, that results in a smaller radius value of 6.27 million meters. So putting this into perspective, when starting with the sun directly overhead and traveling 5,400 nautical miles, or 90 degrees longitude, the sun drops down to 0 degrees. For the moon, however, we only have to travel 5,300 nautical miles, which equates to 88.7 degrees longitude for the moon to drop down to 0 degrees. Putting it another way, if we see the sun as if it is traveling along a celestial sphere with the radius of the Earth, then we see the moon traveling along a similarly slightly smaller celestial sphere. And that's what we're showing here with a side view of where the sun and moon appear as the observer increases their ground distance. So the scale is millions of meters, both directions. And with the sun, it's at the 6.3 million meters. The moon's 6.27. And then if we multiply by pi over 2, we get the base radius, which is 10 million meters for the sun and 9.8 million meters for the moon. So now that we have that background out of the way, we can actually analyze the data. And you can see here the path of the center of totality spanning across the US. And the data for the eclipse path is available as a Google Earth KML file from this NASA website. It tells us precisely where the center of the eclipse shadow is cast at a given time. There are 6,770 data points at 1 second intervals spanning from 6 p.m. to 7:45 p.m. for 112 total minutes. Next, the latitude-longitude coordinates for the ground positions of the sun and moon are needed over that time span. I wrote a Python script to extract this information using the AstroPy module. This allows us to calculate the distance along the ground from the observer at the eclipse shadow to both the sun and moon positions, giving us a base distance of our triangle. I also extracted the altitude measured in degrees of the sun and moon above the horizon for the observer, but these are for reference only. They represent an optical position in the sky, and we need to use the true physical position. The final measurement needed is the height of the object doing the occluding, which in this case is the height of the moon. What we're going to do is assume the moon is fixed at the 6.27 million meter height we found earlier, and assume it is only an optical effect that causes the apparent position of the moon to drop in the sky as we get farther and farther away from it. The following table summarizes the known and unknown parameters. So first we have the center of the eclipse shadow, latitude and longitude, which we got from the data file from NASA. Then comes the observer elevation height, where we can take those lat-long coordinates and upload them to gpsvisualizer.com, which will export a CSV with the elevation data. Then the sun and moon ground position, latitude and longitude, which is generated in Python. We have the ground distance from observer to sun and moon, which is calculated using Haversine from those latitude and longitude coordinates. The height of the sun and moon is what we looked at earlier, and we're going to assume a fixed height over the observation period of 112 minutes. There's the observer angle to the sun and moon, which is generated in Python, but we're not going to use it because it is the apparent position. And then finally, the physical occluded angle from observer to sun and moon, which we don't know, but we can solve using basic trigonometry. Our assumptions are as follows. Number one, the sun and moon are at different fixed heights as they travel east to west. We'll consider any change in height negligible over the 112-minute observation window. Number two, assume the physical positions of the sun and moon are in a direct alignment with the position of the observer. That is, drawing a straight line from the observer to the physical location of the sun is going to intersect the physical location of the moon. Third, the light from the sun to the moon, and likewise the shadow from the moon to the observer, is going to follow a straight path, where refractive effects of the light are negligible. Since we're using physical and not optical positions for the sun and moon, optical effects do not apply. And lastly, no corrections are going to be accounted for ground curvature. And here are the objectives of the analysis. Celestial theodolite calculations generally involve calculating the height of the mountain peak using a triangle of the physical geometry and then comparing to the known height in order to evaluate the measure of success. Lacking certain key measurement values forces a different tactic for this analysis. In this case, over 6,000 data points are available to analyze, so instead, success will be measured in regard to consistency across the full dataset. We don't know what the height should be, but can we consistently calculate the same height across all the data points? These 6,000 data points aren't simply a similar measurement taken over and over again. Since the sun and moon are moving in the opposite direction as the eclipse shadow, the distance is constantly increasing from 2.6 million meters to 7.7 million meters, which is an increase by a factor of 3. Likewise, the altitude angle from the observer to moon drastically changes as well, going from 70 degrees down to 19 degrees, a change of 51 degrees. And then the azimuth to the moon sweeps out 140 degrees. The observer latitude changes 30 degrees, and the observer longitude changes 60 degrees. The observer elevation is fairly consistent except for this mountain range over Mexico. So the key parameters vary quite a bit over the data set. Now let's get into the actual analysis. The first step is we're going to assume the height of the moon is fixed at the 6.27 million meters number we found in section 2. H moon equals 6.274 million meters. Step 2, calculate the occlusion angle using a right triangle where the base is equal to the ground distance from the observer to the moon and where the height is the moon height. So the occlusion angle becomes the arctangent of the height of the moon divided by the distance. Step 3, we're going to make another right triangle from the observer to the sun using the same occlusion angle from step 2. And since in a solar eclipse the sun and moon are lined up with each other to cast a shadow on the observer, we can assume the angle from the observer to the moon is the same as the angle from the observer to the sun. So now we're solving for the height of the sun, where our equation is height of the sun equals distance of the sun times tangent of that occlusion angle. And that's all there is to it. So now we just have to perform this calculation for all 6,700 data points and then calculate average and standard deviation values. The average comes out to 6,374,000 meters, which is very close to the 6,371,000 for the Earth radius. And then the standard deviation comes out to 6,200 meters, which is less than 0.1% of the average, which indicates the data is highly consistent. This is showing the height of the sun plotted out for all 6,000 data points, and the result is very flat. This is versus time. We can also show it versus distance. And the key point to consider here is we're actually starting the eclipse here, and the distance gets smaller and then gets bigger, so it's actually going over itself exactly, and it's so perfect you can't see it. So if you're thinking the reason it looks so flat is because the amount of globe curvature at this scale is negligible, then let's take a look. It most definitely is significant, which you can see here is 4 million meters at the end, which would be very significant compared to the 6 million meters of the sun height. And since we didn't have to account for it in the calculations, that is very telling. And then lastly, let's look at the physical angle versus apparent angle. There's a discrepancy between the physical angle that we calculated and the observed angle given by Stellarium, even when it does not include refraction corrections. This disparity is shown below, which increases the lower the angle gets, similar to what we saw with the profiles of the celestial sphere. The sun and moon appear to be lower than their true physical position on account of optical influences. Here we can see the physical location of the moon is at 40 degrees, but the apparent is at 20. So there's a pretty big disparity there. Celestial sphere. The sun and moon and here's a spreadsheet showing the data. You've got the eclipse path, the sun, latitude, longitude, and distance calculations. Same for the moon. And then here's where I calculated the sun height. So you can see there's just a lot of data points here. And then you've got the average and standard deviation. So in conclusion, the relationship between the sun and moon during the total solar eclipse can be modeled out with very basic trigonometry while maintaining good consistency for the duration of the event. It is not necessary to make any corrections for ground curvature, nor to correct for refractive events diverting the path of the sun's light. This study does demonstrate that there is a difference in the physical position of where the sun and moon actually are located versus the apparent position of where we think that we are seeing them due to optical effects. Even the globe model agrees on this point. This raises the question, is the ground beneath our feet curving, or is it the sky that appears to curve due to the nature of how our eyes perceive it, notably with the same radius value at which the Earth supposedly curves? I leave it as an exercise to the viewer to draw their own conclusions, but this only scratches the surface, and there's so much more to explore. And then let's briefly go over some things I have here in the appendix. So if you're wondering about moon height over time, here it is mapped out for 2 months with the eclipse happening here at April 8th. And it is changing by about 10,000 meters over that duration. If we zoom into the period of the actual eclipse, you can see it's going from 535 to 570. So it's less than 40 meters change, so not very significant. And when I plug the numbers in with the varying moon height, the average number for the sun height only decreases by 1 meter, and the standard deviation decreases by 10 meters, so it's not that significant of a change. And then earlier we were talking about the 88.7 degree longitude change for the moon to go directly overhead to drop down to 0 degrees. So here we have an observer directly under the moon at point A, and then at point B is that 88.7 degree longitude difference showing what it would look like on the globe model. And since we have a right triangle here at point B, it's just a matter of taking the cosine of the adjacent divided by the hypotenuse. So you can see the math here, and it comes out to 275 million meters. Now we're told that the moon is 350 to 400 million meters here in this range, and what we're getting falls a bit short. And then lastly, you might be wondering how you could solve this same process on the globe, where you're solving for the sun height. And it's very similar, but you have different triangles. And then in this case, you're actually accounting for the Earth curvature. But the problem occurs when you have any triangle, the sum of its 3 sides has to equal 180 degrees exactly. And so if I assume the minimum distance to the moon of 350 million meters, what happens is this distance to the sun angle and the observer angle, those two alone add up to more than 180 degrees, so it's not possible to make a valid triangle, and it doesn't work.
Lost the triangle fight by default. Love it.
So I hope you enjoyed this presentation. I'm sure there'll be more discussion in the future. Thank you.
Damn.
So
Damn.
at the end there, I totally forgot about the end. So they can't even triangle their own.
They can't
They can't even make
participate
their own
in
triangle?
the triangle fight. They're not even
What?
allowed. It's like, hey, you could, right?
No.
We could try it, but nope, you don't have a triangle. That's not valid. You have this curvature thing over here that you have to look at, that you have to handle, so we can't even double check y'all. But that this is probably like the coolest thing that I've seen from the celestial theodolite, Brian. You're the man. Right here in your conclusion, when you're like, so if I just like, if so, the principle, if I'm understanding, is you look at the celestial theo and mountain occlusions and star timing, and you're like, okay, they're making claims of how do you get the height of the star? And you were like, I'll do you one better. I'll do the sun. And I'll use when the moon is occluding the sun as my occlusion timing, and I'm going to use the same trig to get the distance. And when you do that, look, all the celestials actually travel in a flat path above everyone, everywhere, all the time. That's the conclusion. That's what you figured out. And then when you come to isn't it curving? Like, well, what is curving? Because you're really, the only time you get curve is when you mathematically, compute the arc of a sun, the arc of a sun path, the arc of a moon path, the arc of a celestial as it rises and sets over the observer. And you did a great job narrowing that down, drawing the same conclusion that we did, and independently corroborating that the celestials are in fact on a plane above all the observers. Right? It's awesome.
Yeah, man, pretty good, pretty good.
So I recorded this a week ago, and since then I've been playing with it a little bit more, and I have refined things a bit. Most of my error came from the misalignment between the angle of the sun and the moon. It's perfect at one time in the eclipse, and they slowly drift apart. And at the end, it's like off by 6 arc minutes. So if I mess around with that, I can actually get the error much lower, and it's like 200 meters of standard deviation. But I'm still messing around with that. I'm not ready to present that one.
That's some of the lowest standard deviations I've ever deviated.
Yeah, that's 30 parts per million. Crazy.
I like how they say that flat earthers don't bring evidence, do science, can't do math, and certainly don't present statistical studies with average and standard deviation metrics. But look, our boy Brian does all that. Just saying. For like completeness or whatever.
That was a dope Prezi.
Yes, God,
That
that
was
was
awesome.
excellent. Excellent. Like when we reached for the community, I had no idea that you'd be doing awesomeness like this. To be honest. Far surpassed my expectations.
So we
Yeah,
did
there
this.
should be like
Yes,
there should.
sorry, go ahead.
Oh, you're good. Go ahead, Mammy. You first.
I was just going to say, so he did the celestial theodolite on the eclipse. That's pretty crazy.
Right? Who'd
Yep.
have thunk? He was like, "Oh, you guys are doing cool stuff. I want to do cool stuff too. What can I? Oh, I know. I'll do this." Like nailed it.
And it was actually Dr. Mike who inspired me.
Nice.
Because at the time when I was doing this, he had just found that h plus d squared over r relationship. And the key was he found that using the observer angle. And I didn't think I was going to be able to solve this without having the occlusion angle. But because he solved that, I thought, maybe I can do it with just the observer angle. And so I just persisted because I believed I could find a solution. And
You
eventually I
did,
got there.
by getting this distance, by using lat long
Yeah.
and doing ground position. Yeah, that was crafty. I like that.
Gotta get creative.
How do you get this distance? Well,
I can't believe I
Brian,
never thought about them not even being able to do a triangle.
well,
So,
to be
Brian,
fair, Nathan Oakley says it all the time. Sorry.
Brian, you said you've been doing some more poking and more digging, and you have, I imagine, a revision of this you might be making. Is that correct?
Yes.
Okay, cool. Before you put that out, give me a shout. I wanted to talk to you about a point or two that you make really early in this presentation. It's just a matter of perception, something like that.
Sure. Will do.
Sounds good. Working together.
D3, I can tell from his tone that he's not impressed and he's going to do better right now, I think. He's going to bomb her.
I don't know. I'm not doing nothing, man. I'm standing here with my thumb up my yammer. Like really, no. Brian's doing a great job here. That's not the point. It's just something we want to talk about. Actually, 2 points about this presentation that really should not affect the process much. So don't worry about that.
I always get worried when Stone's like, I have a couple critiques to throw in. I'm like,
Dude,
I got
Get out the blade.
Listen,
Stone got the blade. Look out, man.
you got to be worried when he's like, hey, can we meet in private? I'm just kidding.
Well, no, I don't want to piss on the kid.
No. I'm
This
just
is all
kidding.
fun and dandy here.
No, listen, yeah, I think we all had the same reaction. But I thought this was great. I watched this 3 times now. I'm not gonna lie. Now that it's public, I watched this 3 or 4 times, and I like it every time. And I like
Yeah,
DM all
this
the work
is
that went into
this
it.
is my
more to
second viewing
explore.
too, and I know exactly what you mean.
Yeah, you did fantastic work, man.
Thank you.
Oh, could I get the link to it?
Nope,
Oh,
not allowed,
okay.
Eric.
Not allowed. All right. Well,
Not
Yes,
for public
FE only.
consumption.
You need clearance.
but I'm not the public.
You are the librarian. I think that has to count for something. I don't know.
Okay.
All right, who wants to follow that masterpiece?
Oh, dude, I'll take a shot. All right, so I don't have anything formally prepared in terms of like a Prezi and whatnot, but I did want to go over a couple of key things over the past 2 years that really, changed the way that I look at things. So starting off here, we have the introduction of Bennett. The first time he came on was on Witsit's what's it called? In the Field podcast. And what he laid out with kinematics and dynamics was just like we've heard Witsit talk about it multiple times, but like something about the way he went over it just finally clicked. And then understanding that relationship between kinematics and dynamics and how mainstream conflates the two has just been super eye-opening and kind of like uh, refreshing to understand, like to have that piece of information to understand like why they had to create an entirely fake framework to make it seem like they had like a dynamic claim over why celestial bodies move. And then like further taking it to the point where you can understand the math that they do, where it's just the ratios of constants based off of the periodicity. So, and then like the reduction, via algebraic canceling out, you can reduce the dynamics to kinematics in such a way that the dynamics aren't even actually like, the way that works out, the dynamics that they're asserting couldn't possibly be the actual cause. So, going through all that and understanding the difference has been a profound awakening in terms of cosmology, because nobody knows why these bodies move, right? But they move with a periodicity, and men have just created ratios of that periodicity and turned them into distances, etc., and velocities. And it's just kind of an internally self-consistent framework that's been presented as dynamics, as it's been presented as reality, and that's not anything close to what it is. So that's been extremely impactful. uh, and then of course the lab frame, right? The significance of the lab frame's roles and all of these ratios and constants, and how to interpret experiment, and different ways you can analyze. Did this frame satisfy conservation laws? Does it making the correct kinetic energy potential? You know, things like that you can do to verify the validity of a frame, and just like understanding that process was extremely helpful. And then moving on to Dr. Mike more recently here, we went, we've been arguing flat Earth versus globe for a hot minute now, and right around the time that the final experiment happened, it was like looking pretty grim there for a minute. And Mike came through and was like, have you guys ever heard of the null hypothesis? And like completely changed the framework of argumentation. And then it just made it like very logically clear that the globe was derived entirely from the position of apparent bodies, and the geometry of that is asserted as like, oh well, these bodies would only be visible at these angles at this time if the earth is a globe, etc. And none of that turned out to be true. And then later on, he came up with the celestial theodolite, which uses the intersection of the terrestrial and the celestial to kind of add like a manipulation of the independent variable there, which so uh, by making the process more scientific and more logically cohesive, it really opened my eyes on how to continue the conversation and how to make meaningful logical arguments, and how to build, your evidence for the thing that you're not proving, but you're proving what it isn't. So like I really like that concept and that framework. And so that's extremely pivotal in how we argue and how we look at things now. So shout out to Dr. Mike.
Cassander and Dr. Mike, yeah. I think they were both here. I think they both left. I don't know what happened.
Yeah. Cass was here for a little bit and then he bounced. And then at the end of that, I wanted to add in Man of Stone mentioned earlier that he was the blade of truth. So one of the things, and this isn't really like I don't really know how to articulate this in terms of a skill or whatever, but I like I like what Stone has brought to the table in terms of quality assurance and like, like I find like we were talking about this earlier. Am I the problem in the Prezi? Like, am I misinterpreting something? And like, so I kind of have like a rule of thumb when I'm going to present something new that I'm unsure of. I go, if Man of Stone asked me on the spot to justify this, would I be able to do it? And if I can't do it, then I don't
Out
talk
you
about
go.
it.
Not in the Prezi. Yeah, I get you. That's a pretty
Yeah,
good
bro.
barometer.
Yeah, that's a
Wow.
great one.
What can I say?
Yeah,
Wow.
I don't know how to say that in terms of like that's something that that's just something that you've taught me where it's like, you can get carried away with math and your ideas of what you think is happening. And sometimes the math works out really good and you're like, oh my God, dude, this must be it. And it's like that's exactly what the mainstream lads did. So like don't ever fall for that, It math obviously isn't reality. It makes useful models, but don't don't ever conflate that model for the actual thing. And that's an important concept that Stone has instilled in me. That's what I wanted to articulate. There we go.
Excellent.
Duly complimented. Thank you.
Nice.
Yeah. Stone has been a great value. And Alan, this is Shalom. Yeah, I've talked about this with you before on Discord. The Cassander's lessons on minding our K's and D's, the Kinnies and the Dinies, was a game changer for me too, big time, because so much of their argumentation, so much of their postulations are conflating the two, and having a comprehensive understanding of kinematics and dynamics and learning how to differentiate them has been a big tool for me when engaging people in public outside of these social media platforms.
Yeah, absolutely. It's like
Pivotal.
having the difference between kinematics and dynamics is like a secret weapon. It's like suddenly they're like, what? No, but it's the same. But I see it move in the sky.
So
Exactly.
can I make a comment? I'll make a comment.
Absolutely.
They should know.
Absolutely.
They should. I just want to say they should know better the difference. I don't know. Anyway, I just want to say they should know that.
Get him, Eric. Is that all you got, though?
No, we actually just saw a great conflation of kinematics and dynamics from Stone's adventure with trying to hook up with Dr. Guy from the internet.
Inventor of email, of all things, MIT
Yeah,
4
yeah,
degree guy. Oh, okay.
he tried to wield kinematics against us while claiming their dynamics, and then like gaslit everyone, and like everyone in the Twitter comments was like, "No, you're conflating the two. You just showed us a bunch of kinematic equations."
Yeah, all
and
the
asserted
lads called him
dynamics."
immediately.
And
Like, yeah.
and instead of going, "Oh, you're right, my bad. Here's GMM over R squared. Here's the droid you're looking for." Instead of doing that, he was just like, "Nah, you guys are all retarded."
Yeah,
I did rather enjoy that thread.
spending some time with Luca Popov's paper, Newtonian Machian Analysis of Neo-Taconian Model and Planetary Motions. That is a good exercise too, and honing that distinguishing skill between dynamics. And although he's assuming the Newtonian dynamics and stuff like that, you don't have to agree. That's not the point. The point is that he was able to do the Lagrangian for the dynamics with a geocentric model
Frame.
Yeah, Frank. Yeah.
Nice. The forbidden fruit. When you're satisfying your Lagranges and your Hamiltonians with yeah.
Tough.
Ah, you were in the zone there, man.
Tough
What
one.
happened?
Yeah, fumble. It's all right. It's can't have them all. Damn. So yeah, Cassander and Dr. Mike laying down the foundation. I think Cassander was definitely foundational for us. Do you remember he put forth that thing on the tides? The whole he put a paper on geocentric tidal forces, like 3 pages, and I read it, and then I had to do a whole pres on tide. Ended up being like 3 prezzies on tide, which was just like a 6-hour lecture on tidal forces by the end of it. So then I had to trim that down into actual digestible stuff. But he was the impetus to even look into that. Was like, what do you mean geocentric tides? What do you mean gravitational tidal, like gravitational acceleration? What do you mean constructive gravitational wave interference? What do you mean you just add the sun's gravity to the moon's gravity when they're in close proximity, and that's how you get? You're like, what? That doesn't make any sense. Oh, it doesn't work that. Oh, no way. When you do that, all the math is wrong. So I mean, like that whole thing works great. The distinction between the dynamics of that is also pivotal, though. In the moon's gravitational influence, they're trying to pretend like they know the forces. They're using that same formula, but then they're dropping it out and using the centrifugal force with the gravitational, so that the masses drop out. And then they're saying that mass attracting mass is the dynamic force of everything. So I mean, that was another foundational point to see the algebra actually just removed their explanation for the dynamic force of everything.
Nothing better than canceling out the dynamics and ending up with just periodicity.
Dude,
it's a classic.
I remember going to Twitter and starting with that, being like, okay, guys, you know how you guys think mass attracts mass? Okay, we'll see this equation. How is it that there's no mass here? Go. Like,
well,
they were
it
like,
only
well,
applies to objects in the
Oh,
solar
yeah.
system. And it's like, what?
clear everyone
You
for a
mean
loop.
the foundational basis for which you outreach, from which you extend outward from that? So like,
That's what.
no dynamics here, but then you're saying that there's dynamics out there. And guys, so here's the thing: the sun takes over all dynamics here in the solar system. So like when they cancel out the mass, they're just like, well, this other one's so big, doesn't matter, you can just cancel it out, and then it just falls back to the periodicity. Now, when they get into the dynamics that extend out of the solar system, you guys remember dark matter and dark energy?
Kinda.
Vaguely.
Never met him.
Well, the only other mass variable that you could put in is for dark matter. So like there's no like their dynamics is just an insertion of as much mass as they need to make their dynamics work, dude.
Yep.
When they don't have any mass in the solar system, when they don't use mass in the solar system for dynamics, they're like, yeah, I mean, it's all good. And then when they leave the solar system and they calculate from things outside of that, they do the inverse, and they're like, well, now we need unlimited mass to make up the difference.
Yep.
Yeah,
dude.
realizing that was like a vindication of my soul. It was just like, it was, oh, what a relief. What a relief to just get rid, just to cancel out the masses and end up with the periodicity. Nice Monty trick.
I remember when he was explaining it to us, he gave us the proper context. He's like, people knew this for 400 years. They knew that Newton's law is derived just from Kepler, and when you left is really just Kepler. Everybody, like science, knew this as a mainstream fact, and then slowly, over time, they didn't know it, and now nobody knows it. It was like, what? How is that? Oh, that's what they do with everything.
Who was that who said say it enough times and then everybody will think that's the truth?
JFK.
Yeah, someone just like him. No, within the wind of copium that I have had to wade through in this argument, the one I really enjoyed was when they tried to convince us that the sun or rather, the Earth and the Moon, because they're so close together and both so far away from the sun that they are a quote gravitational pair. Oh yeah, that was entertaining, I must say.
Yeah, or in particular, working out the sun's tidal solar acceleration force versus the lunar tidal acceleration force when the sun proximity is at the other side of the solar system, but still exerting a more powerful force on the backward side of the centrifugal cancellation of the moon's gravitational force. Like, oh yeah, that's cool. That's a cool story. Yeah, Cassandra armed us with that, right? And we say like sent us to the internet, and then Mike came and gave us more weapons and honed our framework with the null hypothesis and was like, "Here, go get him." So I mean, definitely pivotal. Definitely thanks both of those foundational people. But they're not the only people. I think a lot of people in this community have been super supportive of everything that we do with questions and in the background, just in the community. You know, always there supporting people like JT, always around, always there, always helping. Right, Shalom, always here, always helping.
Yeah, definitely. Shout out to Tycho Brahe and Ernst Mach. You guys are on.
The original lads. Yeah.
Shout out to Ma.
The original Kepler kinematics.
Yeah, man, we have an awesome support staff here at Aether Cause, and we would like to turn this community showcase thing into like a regular segment. So maybe once every 2 months or so, we'll do, if anyone has anything that they want to submit or anything cool like that, they can, we can start doing that.
Yeah, mini prezzies.
Highlight some of the people in the shadows that are, in the dark, operating behind the scenes for us.
I'm now a huge fan of YouTube videos. So if you want to record your own thoughts, that's some visuals and put it in a video format and send that. That's excellent, well preferred. I seen there's some PowerPoint clicking, there's some Canvas slide, whichever method you want to do, contribute, I think is really cool. I think we got really lucky this week because our 3 submissions are excellent. We get 3, we get 2. We get 2 videos.
We got 3, but we only did 2 because Angling's not here.
Oh, I thought he would show up.
Well, there's hope still, I suppose.
Hope is fading fast.
Hope is on the downswing and closing.
It's trending towards 0. It's going asymptotic or whatever.
Asymptotic, yeah, really.
All right, well, I'm just going to put some people on the spot here. Baron Von Galley, what are you thankful for, or for learning here, or whatever?
Good
Thanksgiving share
Day.
style. Yeah, little Thanksgiving Day share sesh, bro. All right, Galley's not here. Brett, if you're not at work, what are you thankful for?
It doesn't look like he's been around much either. I'll take the heat off for a second here.
Hold on. There's Mike's move. We have movement.
Hold on.
Oh, there he goes.
I gotta step away real quick. Yeah, I just, over the past year or so, it's been pretty humbling, like reflecting on the power of philosophy when it comes to interpreting scientific data. Like the physical meaning of length contraction and time dilation.
Oh, absolutely, man.
Very humbling. Yeah.
How it's just a mathematical cope. Yeah.
I like that word, humbling.
It's a really good transformation.
Dude, pun intended. Am I right? Like a Lorentz transformation.
I laughed, but I was
Is
on
that
mute.
what we were doing?
Yep, same
Dude,
here.
without feedback, I had nothing. I was
laughed hard to
shoot in the
myself.
dark.
Sorry you didn't hear that.
All right.
Are you guys
Nice.
drinking
Life on the net.
again? Are you Lawrence transforming everything again? Come on, man. I felt something happen there. I was like, oh, what has happened there? I just shrunk or something.
Well, you did some math that has no physical meaning in the real world or in any observable frame of reality. And it's like, oh, that feels kind of less. Like, yeah, it should. It has 0 meaning.
Hey,
Yeah, that
I
was it.
wanted to share a little bit something.
Okay.
Awesome. What do you got, Lily?
Well, I was just going to say that I feel so grateful that you guys have allowed me into your company. And I feel so privileged because you know what? You guys are doing the slogging part of it. Like, you guys are sitting there, like, doing the day-to-day slog, because it is a slog. And you're taking this whole movement further inch by inch, like into the realm of legitimacy with real hard work, with real data, with real, like evidence in terms of like, everything that you present here. Like, it's not some shoddy work or anything, you know. You guys are really doing a lot of hard work. And so that's why I know that you will be very successful. I think it'll feel slow right now at the beginning, but at some point it'll be like it'll just grow exponentially, and it'll be because of you guys, your hard work now. And so yeah, I feel so lucky. So thank you so much for allowing me to be your buddy.
Our
Thanks, Lily.
ambassadress, of course.
Nice. That's awesome.
We're very honored. One second. We're very honored to have you here with us, Lily.
Yeah, I was going to say also when somebody mentioned length contraction and time dilation, that was another early Aether cause foundational deep dive, the analysis of the MMX experiments, the history of it, everything connected to it. That was a foundational Aether cause analysis that was very beneficial. MMX.
Yeah. Splitting a laser beam is one of my favorite subjects to talk about. And like, yeah, that was pivotal in the growth here. Re-examining the history of when men found out that they could split a light beam and recombine it and measure the difference.
You can't measure Earth spin.
Yeah, and then to get into the subsequent gaslight of Einstein's general and special.
Yeah,
it was like my first week here, and I was asking questions about interferometry, and Alan's like, "Fuck it, let's just do a Prezi," and did a Prezi. Yeah, it was pretty cool.
Really, your lesson was an impromptu personal bear impression. That's kind of cool. You got a relativity special serve on first delivery. Wow.
It wasn't personal just for me, but I mean, he was just like, let's just do it. Let's just make it a Prezi.
Well, it sounded like it was just for you, and that everyone else just happened to be here and got to.
It wasn't not just for him.
I mean, when you're having a conversation and you need to show someone something, out comes a screen share and it becomes a Prezi, right? That's one of the benefits of Discord.
Yeah. All right, Bull Knight. What are you thankful for, my good sir? Surely you've learned something here or there, maybe about the globe or about flat Earth or Aether, perhaps.
What would you look and do for Battle of the Beams to try and prove us wrong that one time?
We don't talk about the beam battle or whatever.
Beam me over.
Our Bull Knight might not be there. D3, you got anything cool you want to share that you've picked up over the last 2 years? Maybe from here or just from the conversation in general in the flat Earth scene. Something cool you want to share?
Oh man, there's so much. All of it in general, really. But definitely a couple of the things that you mentioned, like the null hypothesis. I never even thought of that. And the Keynesian dynamics, that was a whole difference maker for me because I didn't have any understanding of that really before that. And going all the way back to, the stuff that Witz has done in the past. This kind of stuff really, for me, is life-changing because it changes the way I perceived the importance of where we are. And so that, I think, is the biggest thing for me.
Right.
Yeah. Yeah. And it helps you understand like when other people, and by other people, I just mean like mainstream primarily, like when they try to assert, dynamics of the sky, it's like, you now know that none of that is applicable and nobody knows.
Right. Right. And it's funny because with you guys over the last 2 years, we already kind of had through the discussions, we arrived at, there is no empty space. And in the last year or so, following some of these science folks that I follow, talking about a lot of the latest science and the alternative scientists who are out there saying the same shit, like, bro, it's full of it's full of stuff. There is no emptiness. Everything is in motion, and there's vortexing everywhere. And I'm like, yo, the whole flat Earth community has been saying this. Like, so yeah, man, it's there's just so much, all of the facts that you guys do, and thank you guys again for your hard work. I wish I could pay you guys a few grand each at least, because you guys really put in a lot of work. And I definitely appreciate that.
Nice.
Cheers, man.
Well, we appreciate you, D3. You've come through and given us a lot of interesting things to think about. Sometimes you'll be revisiting a subject that I would consider something that it's like I don't care about that, but I'll see you like super stuck on it, and then like a couple weeks later, you'll have done like a bunch of research on it, and then like you'll have like a more you'll like present stuff in it that like I didn't even consider, and I'm like, oh damn, that's nuts. Like you were going super hard one day on the sea level stuff. And I was like, yeah, I don't care about any of that. But then you found that it's just super level all the time. And they, they just stitch together different data points to make it appear as if it's ball curve.
These questions drove me harder though, because I was doing a geodetic survey, or I was doing a geodetic datum study at that point for a president, and he was asking about orthometric height versus sea level versus mean height, and I was like, geez, I don't know, let me look. Oh, it's super relevant and actually pivotal. It's how they make sea level curved
Right?
around the ellipsoid. Wow, how about that? Yeah, D3 always asks on point questions. You can never say that he's babying us, that he's on our side with like softball questions, right? You can't say that about D3. He's got really on point, real questions to make you think.
Sir. All right. Eric, it's now your
Yeah.
turn to speak and tell us what you have learned over the last 2 years.
Well, I want to say I'm glad I opted into Aether cosmology, and I'm glad I wasn't banned. So, we don't need this Earth.
That is the biggest achievement,
Instantly,
actually.
instantly.
But no, I'm very happy to find the group of people that you and the channel that you created, and so I'm glad to be the librarian and help people out. And also about the Michelson Morley experiment, that they kind of just didn't really justify, but kind of just ignored the evidence. I mean, that kind of made an impression on me, that the assumptions that modern physics makes, the mainstream science, as Dr. Bennett says, they kind of just say, okay, this is what we're going to accept and write all the books, and that's what we're going to go with. And so I think that it really shows that you have to re-examine and be careful. So I'm glad to be here and learn some things. And also, people are leaving. I'm talking too long.
Nah, you're good, man. No,
Okay.
yeah,
Anyway, I'm glad
I wanted to ask you about MMX
Oh.
and Ether specifically. So you've said that you didn't think that the Ether's final word has been said or whatever. And
Right. That was a while.
when you look back at like relativity and Ether, like what are your thoughts on the whole thing now?
Okay. Well, as you know, I'm kind of, even before I met Ron Hatt, I was interested in gravity and the ether. Right now, I mean, I still will look at relativity. In fact, I got some comments that, well, I'll go into those later, about Lev Landau was a famous Russian physicist, and he starts off his book on electromagnetism right with relativity, page 1. But I'll talk about that later. I think it has to be reevaluated. Relativity does appear to come up with equations that seem to work when people build things like cyclotrons and things like that. And but I'm not 100% sure. I mean, I think there is an alternative, and so I'm still looking into it because there's a lot of material to examine and go over. So I don't know. Did that answer your question? I don't know. I'm still
on the fence. Gotcha.
Yeah, well,
perpetually on the fence, dude.
I'm on the fence.
It's awesome.
I'm doing a perpetual balancing act.
He was trying to see if you inched closer either side yet, and you haven't. You're still right in the middle. Okay.
Yeah, it's just yeah.
I
You
meant
you led with the foundation of relativity is built on a lie of Nicholson Morley,
Then you were
and
like,
yes.
but
then
it's still cool, and I like math.
No, right.
You're awesome.
But I'm glad
I
to
think
be here and know you
I
all.
think it must be said though, Eric. I think everybody here would agree with the statement that Eric here operates at a very tangible level of objectivity, insistently so. And you know the
Yes.
self-awareness is there when making those analytical steps.
So
Well, thank
true.
you. Thank
Yeah,
you.
valued member of the community either way.
I mean, seriously,
Kat,
he
want to
took
take a break from dinner and do an impromptu presentation on what
Eric
you're
took
thankful for?
a major, just to interrupt or add, I guess, Eric took a major magnifying glass to my mathematical work in the past. And I kind of lean on that since then when discussing it with other people and explaining how correct a particular piece of math might be. I don't name names, but I point at people who are excellent at math, clearly, and really paying attention to the figures and actually, grabbing the mathematical shovel and going through every last figure to see if it all really does make sense and really does adhere to reality, etc. And there he is, just saying, "Well, yep, checks out." And I feel all the more validated for that. You know what I mean? That's great stuff.
Oh, yes. That was when I was trying to get the numbers out of the spreadsheet that were shown on the video. I
Yeah, totally, man.
Yeah,
Totally.
but that was before you sent me the actual spreadsheet. But yes, that was kind of enjoyable. It took persistence, but well, anyway, thank you, Stone.
Actually, to
Nice.
add on to that, about my own self, and I'm kind of echoing something that Eric did just touch on, and that is just how many assumptions and presumptions mainstream science make when they're putting together theory and hypothesis. Well, and particularly when they amass their storm of white papers, the things that they are shuffling past the gatekeepers and getting tacit approval is staggering. And when you start to catch them all in series like we do on reading nights here, for example, you get a really grip. I should say a decent grip on the real size of the entire dogmatic story that is mainstream cosmology. And and I have to give credit to the gang here for making that a habit, a weekly thing where we
Hmm.
grab a white paper and we put it under the scope and we read through it. And you know what I mean? We reflect on it on the live, and we essentially mastermind it in terms of analysis. Which I think it's more than just refreshing; it's enriching. It's something where you can walk away and go, okay, now I'm a little more confident about where I stand on that particular issue because of what we did this week. That is a really valuable thing that Aether Cosmology presents. And I'm so glad that all of those streams are forever captured, well, until YouTube flushes them, I
Until we
guess.
get deleted forever. Yeah, that one day.
that
They're all
it's
backed up on Telegram.
it's a free resource, you know what I mean, that people can just go to and index if they want to by keyword sometime, by author even, and get more out of the subject. It's an invaluable resource. And if I were going to point out a second thing about what this has been for me over the past 2 years, it's about AC and not just AC. It's what happens on Friday nights. It's what happens at the clubhouse. It's what happens on EA sometimes. It's what happens all the place when EA goes here and there and everywhere. Um, and while all that frenzy was happening, it was um, it was pointed out to me in a rather lengthy text that there's something that I wasn't really doing much of at the time that I should be doing, and it's something that to be to be absolutely frank, I do not particularly enjoy, but that I need to be doing it out of the regard for the benefit others receive because I do it, and that's debate. And that's why I have been making concerted effort to repeatedly get out there on Friday night and be there for whatever balls come flying at us from the globies. You know what I mean? To pun intended. And it's I guess another skill Yeah, we have to exercise and hone it so that it's not such a pain to use it. But I credit this entire system here, starting with AC, that I was brought to that point by somebody who was listening. Let's put it that way.
Nice.
Dude, that's so true. Every time you would do like a guest appearance on Flat Earth Fridays or some Twitter or some sort of community thing, people would leave comments like, where do I find more of Stone speaking? That guy speaking is awesome. I need more of that.
Yep.
No, you're phenomenal at it, and I think like your ability to go through meticulously each thing that was said is it's a skill that uh everyone really needs, right? And like I think you do it by taking notes, and it's like I don't know if people know this, but taking notes is always an option, and it helps tremendously in conversation. I mean, and arguing as well. So
Yeah, thanks, man. I do appreciate it.
so yeah, the effort that you put in has not gone. It's not gone wasted. It's good stuff. And then the skill of debate, like you were saying, super important, especially in these conversations where you're trying to sway people via the cosmological beliefs using whatever uh whatever means of communication that is necessary to bring it to the level of where the conversation's at is a very important skill set to have. And yeah, getting out there every week practicing it is super important. Now you just made me feel guilty for not going to like the last 3 or 4 weeks of Friday. So
well, there's always
just straight social shamed me into making sure I attend Friday. So thanks.
That's the best thing about it. There's always next Friday.
Well, I'll bring you back up. Alan over there inspiring me to do more all the time, right? Personally, like, oh, you doing a prez? Nah, I gotta do a prez. Oh, we're going over here to this thing I don't want to do. I guess I'll do that too. Oh, we're speaking over here. Oh, I guess I'll speaking on this show. Right? Always just, I guess, bringing it forward, dude. So bringing me forward personally.
Well, when I said you guys do a lot of hard work, I forgot to add that it can also be unpleasant. So you guys deserve even more credit because dealing with all those unpleasant baboonish globers, that's no fun. So it's a huge sacrifice you guys do. But in any case, yeah, I guess with time, you guys just won't get excited with, what those monkeys do. They're always going to try and fling poo at you or whatever. But you're just going to be calm about it. But, yeah, so it's hard work and unpleasant work. So thank you again. You're so appreciated and loved. And Eric, too, even though he's a bit of a traitor, we still love you, Eric.
Bit of a traitor.
Yeah, the Globers aren't so bad. The Globers aren't
well.
so bad as the anti-flat earthers that vex the soul. It's looking at you, Jesse.
Well, Kat's gonna tell us what she's learned and or is thankful for.
I was or I am still. I've always loved maps. I'm a map geek, so Shane's presentations on the celestial and terrestrial sphere have been near and dear to my heart, and I think have helped me become a more educated and well-rounded flat earther. And the community in general, it's just been awesome to see people step up and come about. So I'm thankful that all of you are here and continue to show up and continue to support these gentlemen that started this and that continue to push it forward every week. Like 104 in a row. This is pretty monumental. So special thing to be a part of. So thank you, gentlemen, for what you have done, started, and have continued every week.
Thank you, Kat.
Oh, nice. Thank you,
Wonderful
Kat.
words. And yeah, Shane, your work on maps and drilling in the conceptual models has been profound. Like the idea of like, do you think you live on a map, bro? Like it's been insane. Like it sounds so simple and straightforward. And it's like, even though I've heard you talk about it for like, the last year or so before you even got to where you're at now with it, it was like there was parts of it that I thought I understood that I didn't understand. And then like hearing you go over it 100 different ways, it's finally sunk in where it's like, oh, you accidentally thought you lived on a map. Classic rookie mistake, dude. Like
Yeah.
now it's like so glaringly obvious that it's just like, yeah, I mean, if you think you live on a map, then yeah, it's a globe for sure.
Dude,
or whatever.
to be honest, hearing you and others argue the map like debate with the things that I say is like the warmest feeling that I've ever had. It's like, look at them nailing it. Oh, love it. Like, to see your boys argue your points to completion in your absence is great. That's probably the mark of a true good community.
Yeah, that's one of my favorite things to experience.
But at least it got lots of water.
All right. This has actually been a super productive first iteration of this. This has been great.
Yeah, and dude, next up we got Kenbo, if he's there. I'm thankful that Ken has his lighter today. hasn't had to go searching for it.
See, if you get a zip, you never lose it.
I imagine if he doesn't find the lighter, he'll just start a fire by like rubbing twigs together or doing something like that, like he'll make a fire. You know what I mean? He's one of those guys.
He's a real flint somewhere. He'll find it.
I appreciate you taking my line. That was going to be my line. What are you thankful for? I have my lighter. No, I'm kidding. Man, there's a lot. But I'll be honest with you, being here like from the start to now of this whole thing with Dr. Mike, the celestial theodolite, that's been like a freaking odyssey, man. It just trips me out how simple it is. But I found out today, somebody told me y'all use stellarium, so it's a globe.
Oh, dude.
I got
Still get that.
Dude, we tried so hard to slip it under the radar, but like the Globers called it out immediately. So
they found
were
it
like,
in my
"No,
source code real quick. It has been.
I was gonna say I'm kind of glad people brought up Dr. Bennett, because every now and then I go back and I listen to his presentations because there's just a lot there for me to learn, a lot to grasp onto. And he does really freaking well doing it. Those are two people that I'm glad I got to see come in there. Really, this both of them they've been fantastic. I thought he was going to hang around. I saw him in here earlier. Him and Witzik came in.
Yeah, I saw them in here earlier too. I want to add one thing, guys. And they're not here, but I'm very thankful for the whole Flat Earth Friday spaces that used to be held. I wish they never finished. I thought they were going to come back. They didn't, but that platform, it linked so many of us, you know what I mean?
Absolutely.
Yeah, that's how we found you guys. I second that.
Dude, getting out there and doing that Friday debate thing like Stone was just talking about, that consistently doing it brought us all together, man.
Yeah, man. Yeah, man.
Oh, that was funny. Because I remember you coming to Flat Earth Fridays, and somebody was telling me, "Hey, you need to check this one out. This guy's coming in. He's going to talk about the Aether." And I'd been listening to people that ridiculed the Aether, and so I was like, well, I'm going to be there. It's Flat Earth Fridays, but I'm going to come with hard questions. I sat there for about 30 minutes, and I was like, I need this guy to teach me some more. It was hilarious because I really thought I was going to go there and give you a hard time. And I was just like, nah, I got a lot of questions I want this dude to answer now. So that's another thing I'm grateful for. I remember that night.
Damn. Nice.
Yeah, I've heard that a few times from from various people that listened in on Flat Earth Fridays, and they were like, "Yeah, I thought that the Aether stuff was a bunch of DS," but then hearing you talk about it, like I want to understand more. I want to learn more.
Well, you know where it comes from, right?
Yeah, but it's all good.
Yeah. Well, I mean, they're they're kind of high profile people. People getting into flat Earth, they come across them, and they have good arguments otherwise. But that's one subject that is just, man. You could be talking to them, and they just feel like you're their buddy or something like that, and then all of a sudden you bring up the ether, and there goes that.
Well, you know what they say: one man's trash is another man's treasure, or something like that.
Or medium.
Oh yeah, that's a good one. One man's medium is another man's non-medium. Pretending to be a field, acting like a medium, or whatever. What's that Robert Downey Jr. movie where he's like, I'm a white guy pretending to be a
Yeah.
brown guy or whatever?
Yo, I'm thankful for Alan's quick quips. Like he always has some cool shit to say. It's hilarious.
Yeah, let's get thankful for the
Like-
Alanisms that are its own language that makes
Yo.
people say the wrong thing all the time, but it's funny because Alan said it.
Totally.
Exactly. Like, bro, imagine Alan as a fucking science teacher, bro, and he's like, yeah, so you got your kidneys over here, bro, and you just do it like this. Like, it's so funny the way he breaks stuff down, but it makes perfect sense.
It's awesome. All right, Lily, you went earlier, so we're gonna skip you, but maybe we'll come back to you at the end if we want to hear about some coffee. Giving you a little heads up if there's going to be an ad read at the end or not, and whether or not how long you want to make the ad go for is up to you. So we'll continue on. Amazing, Brian. I want to tell you that I'm thankful that you're here because,
too. My God.
dude, you've been such a tremendous help. Aside from showing that the sun and moon move parallel to the ground, and that there's actually not 4 million meters of curvature in between us at any time, was amazing. But aside from that, you've helped me with so much on the back end of the spreadsheet and stuff, and going over trig and finding out if things are circular or not, and just really going down that journey with me and helping me learn and understand things. And you've even gone over, you've even had to go over things multiple times with me to until I got it. And your patience has been tremendous. So I'm very thankful that you're here. And but if you want to talk about anything else in terms of like what you've learned or anything like that, the floor is yours.
You're very welcome, Alan. If I were going to pick one thing, I think I would go with the null hypothesis, just because it's so game changing.
Yeah, having that cohesive framework to stand on is tremendous.
Right.
It's kind of obliterated all the Globers, huh? Like, there's not really much they can do about it now.
Well, it took what we were doing sloppily and it like unified it and standardized it. It's like, listen, just argue for trying to falsify a null instead of trying to poke holes in the globe without replacing it, right? It took falsification as independent of replacement and made it like an argumentative framework, which is wonderful.
Yeah.
Stick with the null hypothesis. No way. No way. I'd
I
rather
think of that
gaslight you.
logical element as kind of an intellectual fence between us and the Globies, that if you want to talk to us about this shit, you got to clear the fence. You know what I mean?
True that.
Good point.
Right. Pavel, my non-English speaking brethren, how are you, good sir? If you're not able to speak, it's all good, but shout out to you, homie.
Yeah, you could just turn on your camera and do sign language. We'd get it. We'd get it.
Do some signs.
Heavily in tone.
All right, and Shalom, I think you went earlier.
Mr. Ryan just entered the room. How about that?
Did I miss my chance to go? I go.
You
Have
did.
John.
Nope, it's your chance now. What's up?
Yeah, I'm thankful you guys help facilitate such a creative environment where ideas can grow and develop without dealing with like the time wasting obfuscation of other debate places. There's a certain level of peace that's here, and I think it's due to the standard of behavior that's upheld and kept. And there aren't many places in this arena or community where that standard is upheld. So I'm thankful for that.
Nice.
Yeah,
Seconded. That's
I
amazing. Yeah.
second that notion.
Awesome. Well, it's good to hear. Glad to facilitate a nice place for ideas to grow and shit ideas to die.
Amen.
All right, we got
And
we got wi- we
also
got
the righteous six piece that I was given to enforce to enforce
To cut 'em
the
down.
stability of the server. I was given by those on high to shoot those who try to disrupt our peace and facilitation of peace. I'm thankful for that too.
well said.
Those who kill creativity shall be killed. There you go.
Shalom went
Callie, I'm so
earlier.
glad you're willing to shoot first and ask questions never later. Whatever it is.
Metaphorical shooting allegedly.
A metaphorical question will be asked.
An interlocutor's got to know his limitations.
All right. Let's see, Mister. That's hilarious. Your name's Mister now. That's great.
Yeah. You like that?
That's on point, dude. I love it.
Yeah,
Anyway,
thanks.
we were going over what we're thankful for / interesting things that we've learned over the last 2 years that are like pivotal to, our understanding of cosmology and whatnot in these circles. So if there's anything that you would like to share on the spot, you have your choice there of thankfulness or educational stuff.
Yeah, it doesn't have to be Thanksgiving Day theme. At some point, we pivoted, so it's up to you.
Yeah, I just started with that because it seemed like an easy way to transition into it, and then people would talk about something that they learned along the way, and that's been tremendous. It's been working out great.
Get in the zone and get on the road.
Yeah, no, I could definitely touch on both. I'm thankful that I haven't been shot for any of the retarded shit I've ever said, so I'm grateful for that. And I'm thankful for all of the hard work that you guys have put in that has taught me so much. Points of, I don't know, just the whole dynamic of Aether and where it takes me as far as intellectually. It's definitely heightened my awareness and my understanding of cosmology, but also listening to you guys, like now being in school, has definitely been helpful. Learning about the scientific terms, the logic, the rhetoric, all of it is just huge, and it's actually applicable to what I'm doing now, and so I'm grateful. And also I've learned a lot about that stuff because of you guys and the work that you put in, so I appreciate that for sure. That's what I'll end
Nice.
on. Yeah.
Nice, man. I'm glad you were able to get some real world application out of what we've been learning here and stuff. That's awesome.
Yeah, I mean, it's different when I'm in conversation with like other students in some of the class groups that I have to do. I'm definitely the odd man out, but I think they appreciate me bringing certain kind of questions when it comes to even historical teachings, or when it does come to logic and rhetoric, being able to kind of dispel bullshit in the classroom. It's definitely fun for sure. It's been interesting to see how that all plays out, but it does kind of make me the odd man out in the classes for sure. Like I'm always the one that's kind of questioning things, and that's because of being in these rooms with you guys for sure.
Well, you know what they say, better to be the odd man out than the odd man in.
Yeah, I thought it was something, it was better to leave on the fence post, "Don't drink mayonnaise." What was the old-fashioned tiny thing they said? I can't remember.
It's better to ride on the dragon's back than under the squirrel's wing.
Yes, something like that. It's better to be the dull spoon in the light socket than to dress well on a Tuesday night. So
Yeah,
I've heard that one. Yeah.
All right. Speaking of word salad,
you'll get that on these bigger jobs.
How
Yeah,
are you,
what's
good
up?
sir? I heard you had a couple of things
I'm
you
doing
wanted
pretty good.
to go over real quick before you get out of here.
Yeah, thanks. Yeah, I'm very happy I met you, Alan and Shane, because when I first got introduced to you, it was a debate with McToon. I was like, I don't understand why he's always talking about maps and coordinates. It doesn't make much sense. It seems more like excuses. Now I'm using those same arguments because they're very useful, and you've taught me a lot, and you've been very gracious and trying to teach. And yeah, it's been a great experience. And now I basically understand enough about flat Earth to be fully confident in it. And of course, there are things I don't know, but I understand the general principle. So,
Dude, your
Nice.
your quest for knowledge is awesome to see. I love that you come through and you're like, I know some of this stuff. I don't know any of this stuff, and you don't pretend that you do know like the whole, like every aspect of everything. And that's the correct and way to approach it, because otherwise you're not going to learn anything. So it's awesome to see you come through and just absorb, different aspects of what we're putting forward, and then argue it out in public. It's been great to see it, man.
Yeah, it's also been nice to see you come in hot from a debate, ask us the question that you just got asked, and have us work through it for like an hour so that you're comfortable with it. And then the next time you come back with a different question, and we know that you absolutely nailed the first one. You went back with, confidence that you came in, and your voracious appetite for learning was great to watch.
yeah, some of them it's more of like I think I need a better answer for this because they might not buy it if I use this one. But does that actually wits it, or is that?
It is.
No, that's an account that looks like
that's
him.
the de facto dude.
I heard a turn signal. So it's definitely him.
Yeah.
What's up, man? How are you?
Good. I got like a couple bars, so I might be robotic. Are we all?
Nice.
We're all saying what we're thankful for.
Yeah,
I'm
we're
thankful
doing
that you guys
Thanksgiving
are my
dinner.
friends, and I'm your friend, and you're my friend, and we're friends.
Gay.
And
Gay.
I'm thankful you
oh
went to
man, I was just
Antarctica, so we didn't have
blazing
to.
for 5 minutes, says I'm gay.
Oh,
Yeah, Antarctica. Let's talk about Antarctica. I think I gotta
Dude,
go.
yeah, I'm glad that you went so that none of us had to go.
No, it was cool though, bro. It was cool on the plane, dude. No, I'm thankful for those really clutch last minute coach sessions, cramming in right before the debate that I didn't remember what the topic was. And I came in with the squad, and then we went over everything, and you guys were like, hey, by the way, we've dissected all their arguments ever. Here's anything they've ever said and what they said about it. The clutch little glances at Telegram live time are also pretty cool. Learning new concepts live time in the most awaited flat Earth debate ever. That was cool. Yeah. And then I think, dude, I've obviously haven't gone for a minute, but when we like took the sky back, we took satellites back, we took orbital mechanics back. Yeah, man, there's lots of good times. I
You
think
can't do
that
that.
when we pivoted there, we pivoted to as opposed to just standing on the falsification, we pivoted to oh, wait a minute. These things actually help us. I think that was crucial. It was like a new era in FE, and QE loves it, so that's good.
Nice.
Yeah, it's hilarious because sorry. It's hilarious because whenever I talk with glowers, they're like, "Oh, you can't even explain satellites." I'm like, "Yeah, I'm gonna turn them back on you. Just wait a second."
Yeah, it's awesome.
Yeah, there was a group
Satellite, you say?
There was a group of those things that not only do not support you, but directly do not support you and directly support us. It was like ether, sidereal, rotation, motion. All these arguments that people were running from actually are solidified, like are mutually exclusive proof. So that's important to go through for sure. All your proof are belong to us, as Alan said, or whatever.
All your proof are now ours. Or belong to, I don't remember. But yeah, dude, that's awesome. Yeah, going over the debate stuff and just like that's such a useful part of this whole conversation because it's like all about, refining the argument, making it better, making sure you have every possible citation and an understanding of what's being said in the material to argue it has been, it's basically it's taught me like a new way to learn essentially, like outside of the way that we were, taught in school. And it's been a lot of fun to learn in that way and then deploy what we've learned as like a weapon.
Weaponized
So,
knowledge, yeah, and argumentation for
right?
sure.
Knowledge is power. And you haven't experienced that until someone's brought up a satellite as proof of the globe.
Well, dude,
or whatever.
it's one thing to know a thing, and it's another thing to argue a thing you know. I think we're learning, right? So it's definitely a skill
yeah.
to pick up. You watch
Yep.
Wixit enough, and you think you can just do all the stuff that he does, and you can't. And try it out, and it's like, oh wait,
Dude, I'm like,
how does he lay 9 real live time traps for them to fall into? I could barely do one at a time. You want 2 concurrent traps? Like, okay, all right, I see what he's doing.
bro, I trapped myself one time. I don't know how he does it. I accidentally KO'd myself with my own argument somehow once.
Well, bro, they're
careful.
so like chaotic and illogical, like logically incoherent that you got to set a lot of traps because they're just gonna run around aimlessly. You don't even know where they're gonna go. You know what I mean? It's like, yeah, so satellites, Coriolis. Retard.
They sense weakness and they just lily pad to something else immediately. That's definitely what we notice.
They just spin the globy wheel and hit you with the next scattergun round.
Yep.
Yeah, man. Once you learn how to like, they have like this misplaced confidence that's not deserved. So then you just you let them think that you're walking into some slam dunk for them, and then they will always do it, bro. So,
Oh, but they can say
How do you
word
explain
salad.
stuff?
It's word salad. That's their good excuse to get out of it.
just act like you accidentally said satellite or something, and then act like, oh, you got nervous. Oh, I don't want to talk about that. But, oh, speaking of, yeah. What about those inertial forces, my boy?
Get your real inertial forces around a non-rotating Earth. That's crazy how it can't stay up there otherwise. Whoa.
It is a badge though. I remember getting mine on a Friday night. I got my word salad badge. It's like, oh shit, that's better than the Boy Scouts, man. Like, wow.
Yeah, it is
now
like
I've gotten somewhere.
Yeah, it's a good feeling when they just have to say the word salad. He said, I see word salad in here. I just assumed he was talking to me, but there's a guy in here with that name.
You inspired him.
Yeah, I named it because
Another
people
lad you
say I use
inspired.
word salad.
He was so proud. First time he got word salad or whatever.
And it's not even Globy McGlowface trolling as the name. It's like a real dude.
You're just saying words.
I wanted to touch
You're
on
just saying
something,
words
Alan,
that aren't saying anything.
You're just saying words.
Alan, something that you brought up, like I think actually was a huge deal for me was learning how to read the papers and actually understand actually Stone, he was a big part of this, was being able to read the language when they use terms like maybe and assumed, and you know what I'm saying? Like I never would have caught those kinds of things prior to listening to the reading nights and going through those papers. Like that stuff was incredible. Like you said, it was a new way to learn, and I didn't have any idea that it's right there in their own work. Witsit, you pointed out a lot too with the fact that they know it's geocentric. They know they can't disprove that. Like that stuff is wild when you read it and it's right there in front of you, and people want to just ignore it like it's nothing,
Yeah, a bunch of ways of saying like anything but God.
Yep. Yep.
All right, I'm taking off, fellas. You guys have a good rest of the night.
Later, word.
Thanks for coming by.
Thanks, bud.
Take it easy, man.
Peace.
Yep.
We should wrap up soon. Then we're going
Thanks.
full 2 hours for our nice community night.
Yep, nailed it.
Yes, fully packed.
By nailed it, you
Yeah,
mean
we can go ahead and wrap up.
I was like, you
No,
want me
no,
to
yeah,
kill it?
we
You can
can
do
go
it.
ahead and wrap up.
Okay.
No, I'll exit us out. All right, everyone. Thanks for tuning in to Ether Roundtable 104. Was our 2-year anniversary every Tuesday, and here's to many more. We'll be back next Tuesday to do some more prezzies. We got Glowbusters coming up on Sunday, and Brian Sweet will be leading the Twitter community night. So we'll tap
Hey,
in with
Alan.
the lads this weekend. Yes, what's up?
Isn't this the Sunday we're taking a break on, GB?
Oh,
yeah, we're not
nope.
doing.
Sorry, you're right. You're right. We are taking a break on this Sunday for Glowbusters. My bad.
There we
Thank
go.
you, sir.
There's that QC.
Just to keep it clear.
And we go all day on that early in the morning on Fridays, man. If anybody wants to join you.
Yeah, they start at like 6 a.m. So anytime during Friday. Oh, 8. Whatever. 6 is the new 8.
Yeah, we go from about 8 to whenever.
But yeah, we have an awesome community here. It's not just us. We all learn from each other, and we're all trying to find the best ways to help one another learn. So it's awesome that we all came together and did this, man. I'm so thankful for everyone that came here tonight and shared everything. Whether they had a formal thing prepared or they just were going off the cuff, much appreciated. You guys' support it's why we do this.
Oh yeah, second that.
Amen.
All right, we'll see you guys